So in this video, we're continuing with chapter 6 and section 6.4, that's polyatomic ions. Um, and polyatomic ions are defined as a group of atoms but with one single charge. So for example, you see here NH4, all right? So you have a nitrogen atom and 4 hydrogen atoms, but the whole entity has only one charge, which is one positive, all right? And this is the ammonium ion. Most of those polyatomic ions either have a negative charge of 1 or 2 or 3, and they are negatively charged ions. So the exception is the ammonium ion, which is the only positively charged polyatomic ion. All right, so polyatomic ion, they form compounds, ionic compounds. They combine with metal ions and form ionic compounds. And they are so much in use every day for all the stuff that we use around our lives, and we may not even think about it, but some of the names might be quite familiar, like ammonium nitrate is a fertilizer, or calcium sulfate, plaster of Paris, which is used to make the plaster cast, calcium carbonate, which is an antacid, magnesium carbonate, also an antacid, um, uh, the hydroxides, which are bases, so sodium hydroxide that is used in Drano, and so on, all right? Soda bicarb, sodium bicarbonate. So all of these things are a part of our everyday life. The polyatomic ions are extremely important, and the compounds made from them are also extremely important. So here is a listing of all the polyatomic ions. Now this table 6.7 will be given to you during an exam, but it's really good to get as familiar as you can to know the names and the formulas and the charges of these polyatomic ions. So hydroxide, this is found in all these bases, the compounds that are considered to be alkaline or bases, all right? Most of them have this ion, the hydroxide ion. And so that's an OH minus. Ammonium is the only polyatomic ion which is positive. So NH4 plus, it is derived from ammonia, and so NH4 plus is the ammonium ion. All the rest have got negative charges, and all of them have oxygens. The exceptions being, you have the cyanide, which doesn't have an oxygen, and the ammonium, which also doesn't have an oxygen, all right? So Cn minus is cyanide, but all of them have oxygens in them. And if you look at the way they're named, so these are nitrogen and oxygen compounds. So the more number of oxygens is given the name nitrate. The less oxygen is nitrite, all right? They both, nitrite and nitrate, have the same charges, but one has one more oxygen compared to the other. These are the polyatomics derived from chlorine, and these are very important as well. They are found in our everyday uses. Sodium chloride, chlorate, are kind of bleaching compounds, all right? So you see that the way they're named, only one oxygen is hypochlorite, ClO2, that's chlorite. So oxygen, one oxygen less than that is hypo. Then you have the chlorate, one oxygen more than that is the perchlorate, okay? And you have the carbonate. Now if you put an H plus, attach it to this carbonate, then the charge comes down by 1, and then you get the hydrogen carbonate, or what we know as bicarbonate, right? So this is the bicarbonate ion. And then this is the acetate ion, acetic acid. Dilute acetic acid is what is a vinegar, right? So this is the polyatomic ion present in acetic acid. And then you have the sulfate and sulfite. Again, the 8 more oxygen, 8 is less oxygen, all right? And then if there's an H plus in there, and then it becomes hydrogen sulfate or bisulfate as it's sometimes known as. And then same thing here, hydrogen sulfite or bisulfite. And then you have the 8s of phosphorus, all right? Phosphate, hydrogen phosphate, dihydrogen phosphate, and then the phosphite ion, all right? Again, good to get as familiar as you can with this table. All right, so they either end in 8 or ite, most of them, all right, like sulfate, phosphate, nitrate. So more oxygens means 8, less oxygens means ite, all right? So it doesn't always correspond with 4 oxygen atoms, all right? Like here in nitrate, it's 3 oxygen atoms compared with 2 oxygen atoms, all right? So the exceptions to the 8-ite type of polyatomic ions are cyanide and hydroxide, all right? Carbonate, see if you add this H plus to the polyatomic ion, its charge is coming down by 1. So it becomes HCO3 minus, which is bicarbonate or hydrogen carbonate. Again, the same thing here, you add an H plus to this and it becomes bisulfate or hydrogen sulfate. All right, so these are the polyatomic ions of the halogens. So you see here for chlorine, this is called chlorate when it has 3 oxygens, ClO3, and they all have 1 negative charge. So chlorate is 3 oxygens, chlorite is 2 oxygens. If you have 4 oxygens, 1 more than the chlorate, it becomes perchlorate. If you have 1 oxygen less than the chlorite, it becomes hypochlorite. All right. So applying this now to the polyatomics of bromine and iodine, you'll arrive at the exact same names. All right. Perbromate, periodate, bromate, iodate, bromite, iodite, hypobromite, and hypoiodite. All right, when you're writing the formulas of these compounds containing polyatomics, first again you start by determining what the charge on the metal is as compared with the charge of the polyatomic. So nitrate is 1 negative, magnesium is 2 positive. So you need 2 nitrates to balance out the 2 positives on magnesium, all right? So when you write the formula, you write it as Mg and then you put parentheses around that nitrate formula and then put a subscript of 2. If you didn't have the parentheses, it would look like there were 32 oxygens, all right? And that would be incorrect. So again, the principle here is identify what the cation is, the polyatomic ion is, what its charge is, balance those charges, and then write down the formula that shows the complete charge balance of the ions. So here you're doing aluminum bicarbonate, all right, or aluminum hydrogen carbonate. So how do you write that? Aluminum is 3 plus, the bicarbonate is 1 negative. So again, using the crisscross method, put a parenthesis around the HCO3 and the 3 of aluminum goes there. So it will be AlHCO3 3. Okay, so AlHCO3 3. So writing the formula of sodium phosphate. Sodium ion is plus, phosphate is 3. So the 3 of the phosphate comes to sodium, Na3PO4. All right. Recognizing polyatomic ions will help you name it correctly. All right. Do not use prefixes ever in ionic compounds. All right. So no prefixes in ionic compounds. And that's something that has to be emphasized over and over, because very frequently I see something like dialuminium tricarbonate and nonsensical names that don't exist. All right, so never use prefixes when writing the names of ionic compounds. So this is the sulfate ion. So when you're writing the name of the metal is exactly the same as its elemental name, and the name of the polyatomic ion is also written as is. All right, there's no suffixes or anything of that sort. So sodium sulfate. Now, when you have a transition metal, a B group metal, then you have to determine what the charge on that metal is. So look at the polyatomic ion. It has a 3 negative charge. Therefore, you have to give iron a plus 3 so that the charges are balanced. So iron 3 phosphate, aluminum carbonate. Okay, you don't need this for main group metals. Remember, you only need this parenthesis Roman numerals when it's a transition metal. So here is a whole listing of all the polyatomic, some of the polyatomic containing ionic compounds and what their uses are in everyday life. And as you can see, some of them are very familiar. Epsom salt is magnesium sulfate. Calcium carbonate is an antacid. Soda bicarb, we know that. That is also an antacid. Okay. Antiperspirant, aluminum sulfate. Plasticas, calcium sulfate. Calcium phosphate is a calcium supplement, and so on. Okay. Select the correct formula for each. Aluminum nitrate. Aluminum is plus 3. The nitrate is 1 negative, so B. Copper 2 nitrate. Nitrate is negative 1. Copper is plus 2. So the B would be correct. I'm sorry, this is not B. It should be C. Nitrate is NO3. So AlNO3 3. Iron 3 hydroxide. So iron is plus 3, hydroxide is negative 1, so FeOH3. Tin 4 hydroxide. Tin is plus 4, hydroxide is negative 1, so it would be ASNOH4. All right, naming compounds with polyatomic ions. Again, identify the cation. If it is a transition metal, you do need parenthesis Roman numeral and then name the polyatomic ion. Cation first, polyatomic ion second. All right. So here's a good flow chart for how to name ionic compounds, and we'll get to this part later. So, how do you know it's ionic? If it has a metal. No metal, it's not ionic. All right. So once you've established it is ionic, then look at the metal. Is it an ammonium ion or is it a metal? If it is metal, does it form only one type of positive ion? Then use the name of the element. Or if it's just ammonium, use ammonium. All right. If that metal is forming an ion of variable charge, then you're going to name that metal, which corresponds to the elemental name. But here you will have the parenthesis Roman numeral because it is a transition metal. Now look at the non-metal. Is it a single non-metal? Then it's monoatomic. Then you have to use the suffix "ide." If it is polyatomic, just write the name of the polyatomic. So name the following compounds. Calcium nitrate. Iron 3. The phosphate has a negative 3, so iron 3 phosphate. Okay. All right, we'll stop here.